Good day, everyone. I'm Aditi Godbole from SAP's Data Science, AI, and ML team. Today, we will be discussing the critical topic of data privacy challenges in LLMs. This is an increasingly important area as LLMs become more prevalent in our digital landscape. Let's take a quick look at what we will cover in the next 30 minutes. We will start with a brief introduction to large language models, what they are, and why they are such a big deal. Then we will lay the groundwork by discussing fundamental principles of data privacy. This will set the stage for our deep dive into the key privacy concerns specifically related to LLMs. To keep things grounded, we will look at some real world examples that show these aren't just theoretical worries. We will then explore how the tech world is tackling these challenges and the best practices emerging in the industry. Finally, we will wrap up with a peek into what's coming down the pike in this fast moving field. Think of this as your crash course into navigating the tricky waters of AI privacy. By the end, you will have a solid grasp of the key issues and some practical takeaways for your own work. Ready to dive in? Let's get started with our intro to LLMs. Let's start with the basics. LLMs or large language models are AI systems trained on massive amounts of text data. Think of them as super smart text prediction engines, but they're much more than just fancy autocomplete. These models have some pretty impressive tricks up their sleeves. First, they're great at understanding context. They don't just look at individual words, but grasp the meaning behind the entire sentence or paragraph. This means they can often understand nuances and subtleties in language that previous AI struggled with. Second, LLMs can generate human like text. They can write emails, articles, even poetry that's sometimes hard to distinguish from human written content. This capability opens up a world of possibilities, but also raises some eyebrows when it comes to privacy and authenticity. Third, these models are multitaskers. They can handle tasks across different languages and even switch between tasks without missing a beat. Translation, summarization, question answering, they can do it all. Now, where are we seeing these LLMs in action? They are the brains behind many chatbots and virtual assistants. They are helping create content for websites and social media, and they are even helping developers write code. GitHub Copilot, for example, uses an LLM to suggest code as developers type. But here is the thing, with great power comes great responsibility. As these models become more capable, they also become more complex. And with that complexity comes a host of privacy challenges that we need to address. Which brings us to our next topic. Now that we understand what LLMs are capable of, it's crucial to consider the foundations of data privacy. These powerful AI models process vast amounts of data, which makes understanding privacy principles more important than ever. Let's break down the key elements of data privacy. First, we have data minimization. This principle is about collecting only what you need, no more, no less. For LLMs, this might mean carefully curating training datasets to exclude unnecessary personal information. Imagine you're building a model to predict weather patterns. You probably don't need people's names or addresses for that. Next is purpose limitation. This means using data only for specific stated purposes you collected it for. If you gathered data to improve your customer service chatbot, you should not then use it for targeted advertising without consent. Data integrity is all about ensuring the accuracy and reliability of the data. For LLMs, using inaccurate or outdated data could lead to biased or incorrect outputs. Think of medical diagnosis tool. The consequences of using inaccurate health data could be severe. Storage limitation ties in closely with minimization. It's about not keeping data longer than necessary. Once an LLM is trained, do you still need to keep all the raw training data indefinitely? Confidentiality is important. It's about protecting data from unauthorized access or disclosure. This is particularly challenging for LLMs given their ability to memorize and potentially reproduce training data. Transparency is becoming increasingly important in the age of AI. Users should know how their data is being used. For instance, if a writing assistant is learning from user inputs, it should be clearly communicated. And finally, there is consent. This is about giving individuals control over their personal data. Users should have the choice to opt in or out of having their data used for AI training. These principles form the bedrock of responsible data handling. However, applying them to LLM isn't always straightforward. For example, how do you ensure purpose limitation when an LLM can be applied to a wide range of tasks? Or how do you implement the right to be forgotten when data has been used to train a model? These questions lead us to our next topic, the specific privacy challenges that arise when we apply these principles to large language models. Now that we have established the fundamental principles of data privacy, let's examine how these principles collide with the unique capabilities of large language models, creating specific challenges that the AI community is grappling with. First up is memorization and reproduction of sensitive information. LLMs are trained on vast amounts of data and they have an uncanny ability to remember potential and potentially reproduce that information. This means they might inadvertently spit out personal or sensitive information that was part of their training data. Now imagine an AI assistant accidentally revealing someone's email address or phone number in a conversation. Not good. Next, we have re identification risk. Even if we try to anonymize data, LLMs are so good at connecting the dots that they might piece together someone's identity from seemingly unrelated bits of information. It's like solving a puzzle we did not even know was there. Third on our list is unintended information disclosure. LLMs can sometimes make connections or inferences that reveal more than intended. For example, an LLM might deduce and share confidential business information based on patterns it's learned, even if that specific information wasn't in its training data. Then there is the issue of model transparency. LLMs are complex beasts, and it's often hard to understand how they arrive at their output. This black box nature makes it challenging to trace and address privacy breaches when they occur. And finally, we need to consider the potential for misuse. These models can generate very convincing human like text, which opens the door to things like impersonation or creating deepfake text content. This capability in the wrong hands could pose significant privacy and security risks. These concerns aren't just theoretical, they have real world implications. In our next slide, we will look at some concrete examples that bring these issues into sharp focus. Bring these privacy concerns to a life with some real world examples. These cases will show us that the challenges we are discussing aren't just theoretical, they are happening right now. Let's talk about the GPT-2 experiment. Back in 2019, OpenAI initially decided not to release their full GPT-2 model due to concerns about potential misuse. They were worried it could be used to generate misleading news articles, impersonate others online, or automate the production of fake content. This case highlights the fine line between innovation and responsible AI development. Fast forward to 2023, and we saw some eye opening research findings. A study by teams from Google DeepMind, UC Berkeley, and Princeton University showed that the large language models could be coaxed into revealing sensitive information from their training data. We are talking about email addresses, phone numbers, the kind of stuff we definitely don't want AI systems blurting out. And this really drove home the risk of unintended information disclosure. Then there is GitHub's Copilot controversy. This AI powered coding assistant built on OpenAI's technology faced criticism when it was found to sometimes reproduce snippets of copyrighted code or even include developers' API keys in its suggestions. This raised questions about intellectual property rights and the potential exposure of sensitive information in AI generated code. Lastly, let's look at the recent incident with ChatGPT. In March 2023, OpenAI had to temporarily shut down ChatGPT due to a bug that allowed some users to see titles from other users' chat history. While no full conversations were exposed, it was a wake up call about the potential for data leaks in these systems. These examples show us that the privacy challenges of LLMs aren't just abstract concepts, they are real. They are real issues that companies and researchers are grappling with right now. They underscore the need for robust privacy safeguards as we continue to develop and deploy these powerful AI systems. Now that we have seen the challenges, let's talk about how we are tackling them. The tech world isn't sitting idle. There's a lot of work happening on multiple fronts. On the technical side, we are seeing some innovative approaches. One of these is differential privacy. It's a bit like adding static to a phone call. You can still understand the conversation, but it's harder to pick out specific details. In LLMs, this technique adds a calculated amount of noise to the training data or the model's outputs, making it tough to extract individual data points while preserving overall patterns. Another promising approach is federated learning. Instead of gathering all the data in one place, this method trains the model across multiple devices or servers, keeping the raw data where it is. It's like everyone bringing their recipe to make a meal, but nobody shares the actual ingredients, just the final dish. We are also exploring secure multi party computation. This allows different parties to jointly compute something without revealing their individual inputs. In context of LLMs, it could allow for collaborative model training without exposing sensitive data. But it's not all about tech solutions. We also need to navigate the regulatory landscape. The General Data Protection Regulation or GDPR in Europe sets strict standards for data protection. Companies deploying LLMs need to think carefully about how they are collecting, using, or and storing data to stay compliant. One particularly tricky area is right to be forgotten. How do you remove someone's data from a model that's been trained on millions of data points? It's like trying to take the egg out of a baked cake. Not easy, but we are working on it. And finally, there is a growing emphasis on ethical AI development. This means baking privacy considerations into the entire life cycle of an LLM, from data collection to model deployment. It's about creating culture of responsible innovation. These approaches aren't perfect and they often involve trade offs between privacy and model performance. But they represent important steps toward addressing the privacy challenges we face today with LLMs. Now, let's talk about the best practices. As the industry grapples with these challenges, we are seeing some clear guidelines emerge for responsible LLM development and deployment. First up is privacy by design. This isn't just a buzzword, it's about baking privacy considerations into every single stage of LLM lifecycle, from the initial data collection to model training and deployment. Privacy should be a key consideration, not an afterthought. Next, we have data governance. This involves setting clear policies about what data is collected, how it's used, and how long it's kept. It's about being intentional with data, using what you need, and nothing more. Transparency and explainability are becoming increasingly important. Users should understand how their data is being used, and there should be mechanism to explain, at least in broad terms, how the model makes its decisions. It's about building trust through openness. Regular privacy audits are equally important. The AI landscape moves fast and new vulnerabilities can emerge quickly. Regular checkups help catch and address issues before they become major problems. User control and consent are key. Users should have a say in how their data is used and the ability to opt out if they are not comfortable. This might mean offering different levels of personalization based on user preferences. And finally, there is ongoing education and training. Privacy is not one and done deal. It requires continuous learning and adaptation. This applies to both the teams developing and deploying LLMs and the users interacting with them. Companies leading the charge in AI are already adopting many of these best practices. For instance, Apple does a lot of processing for Siri on device to enhance privacy. Google has implemented differential privacy in some of its language models. These examples show that it's possible to innovate while still prioritizing user privacy. Remember, these best practices aren't just about compliance or avoiding problems. They are about building better, more trustworthy AI systems that can deliver value while respecting individual privacy. And as we wrap up, let's take a moment to look ahead. The field of AI and privacy is evolving rapidly, and there are some exciting developments on the horizon. We are seeing promising research into more advanced privacy preserving techniques. These include things like homomorphic encryption, which could allow LLMs to process encrypted data without ever seeing the raw information. It's still computationally intensive, but it's an area to watch. On the regulatory front, we are likely to see more AI specific regulations. The EU is already working on its AI Act, which could set new standards for AI governance, including privacy protections. This could shape how we develop and deploy LLMs globally. We are also seeing efforts to develop privacy focused LLM architectures from the ground up. Instead of trying to bolt privacy onto existing models, these approaches aim to make privacy an integral part of how the model functions. Now, let's recap some key takeaways. LLMs offer powerful capabilities, but they also present significant privacy challenges. These challenges are real and have tangible impacts, as we have seen in several real world examples. Addressing these challenges requires a multifaceted approach, combining technical solutions, regulatory compliance, and ethical considerations. Best practices are emerging, with leading companies showing that it's possible to innovate while prioritizing privacy. So, what's our call to action? As professionals in this field, we have a responsibility to prioritize privacy in our work with AI and LLMs. This means staying informed about the latest developments, implementing best practices, and advocating for responsible AI development within our organizations. Remember, privacy isn't just a legal requirement or a technical challenge. It's about building trust with our users and ensuring that the incredible potential of LLMs is realized in a way that respects individual rights and societal values. Thank you for your attention. I hope this session has given you a clearer picture of the privacy landscape in LLMs and equipped you with insights to navigate these challenges in your own work. I'll be happy to take any questions and please feel free to connect with me on LinkedIn for more such discussions. Thank you.